Suppose that 1,428 married adults in the US were surveyed, and it was found that 25% of cell phone owners felt that their spouse was distracted by his or her cell phone when they were together. Let's go through and pick out the sample, the statistic, the population, and the parameter, with a reminder that your sample and statistic are what is known, and those are represented with English letters. And your population and your parameter are unknown, and those are represented with Greek letters. So you took a sample. This 1,428 married adults in the US that were surveyed would be your sample. So 1,428 married adults in the US. That's our sample. So the statistic is the numerical value that goes along with that. So in that case, there were 25% who agreed, or felt this way. So that is my statistic, 25%. It's the value that goes with the sample. And as a reminder, when we're talking about percentages or proportions, the symbol for that, for my sample, the sample proportion or percent is a p hat. So I'm going to call this p hat. Now my population, the whole bigger picture that I'm trying to discuss would be, all married adults in the US. And the parameter, what I'm trying to estimate about them would be the percentage of all of these people who feel this way. Now that I am not going to actually know, but it's symboled with just a P, the population percent. I'm never going to actually know it, but I can certainly take this 25% and use that to estimate. As long as I've taken a good survey and done a good sample, I should be able to estimate that probably for the whole population, it's around 20%, and then there's always this kind of give or take margin of error, which we will talk about more in depth later in the course. But that's the idea, is that for these unknowns of the populations, we just can't know those. So we take these samples, we get our estimator or our statistic, and we use that to estimate these parameters. Okay, so let's go ahead and talk about some types of sampling methods. Like sort of alluded to that, you have to make sure you take good samples. So there are a lot of different ways to take samples. One is called convenience sampling. This is a type of sampling that is not random, and it involves using a population that is readily available. Some examples of that would be maybe like surveying the people in your class, or maybe in your neighborhood. Something like that. Right? Easy to reach people. Cluster sampling is when you divide your population into groups and then you randomly select some of those groups. So maybe in this case, you would divide your city into districts. So I would be dividing your population into groups. If the population was your city, perhaps you divide it into districts, and then you randomly select some of those districts. So you've divided it into clusters, and then you sample these clusters. Systematic sampling is when you randomly select a starting point on a list of names and you take every nth piece of data from a listing of the population. So let's say there was a list, there is somewhere, of all Heartland students. Every student who's currently enrolled in a course at Heartland. What you could do is you could randomly select a Heartland name or a student name. This is from Heartland on a list. And then you could choose, let's say, every 10th name from there. So since the starting point is random, then you're going to pick you just pick a number, again, depending on how big of a sample you actually want. So let's say we pick every 10th name from those, and then whoever's names end up on the list, that makes up your sample. And the last sampling method we're going to talk about anyway is called stratified sampling. This is when you divide your population into groups, so it's kind of similar to cluster sampling. But the difference is you take your sample from a proportionate number from each group. So instead of sampling or choosing the whole group like you do in cluster sampling, what you do here is you take a smaller sample from each of those groups. So let's say maybe on this one we divide college students by their major. So maybe we have all types of majors, right? We have math majors, English majors, political science majors. You divide all the students up by their majors, and those are your groups. And then you choose a proportionate number of students from each major. So what that would mean is that if there were, let's say, twice as many math majors as there are English majors, you would randomly select twice as many math students then as you would English students, so that everyone is represented proportionately. So kind of further onto that, if there are, we can write that down, twice as many math majors as English, and again, I'm just making this up, then sample twice as many math students.